Hello. In this video, I'm going to be showing you how to simplify some more complex roots. Also, how to do operations with roots. Instead of square roots only requiring some pair, so let's say the square root of 144, well, we can factor out a pair of 12, giving us the answer of 12. Well, that's a square root. We need pairs. Now we're talking about a cubed root, or even a fifth root. So instead, we now need to make triplets, or a group of three. Or in the fifth root, we would have to find groups of five. Well, for the first example, 54 can be broken down into 2 times 27, and 27 can be broken down into 3 times 9, which can then be broken down into 3 times 3. Well, here's our triplet. We have 3 times 3 times 3. So what we can do is factor out a 3 to the front of the radical, and all that we're left with is 2. This simplifies to 3 root 2. Oh, I'm sorry, 3 times the cubed root of 2. That's something you gotta be very careful of when writing your final answer. Now let's go ahead and simplify the cubed root of 48. 48 can be simplified into 2 times 24. 24 goes to 2 times 12. 12 goes to 2 times 6. And, okay, I'll keep going. 6 is 2 and 3, but that's not going to matter for us. This group of 3 can be taken out, and it results in just a 2. And what we're left with is root 6. So we have 2 times the cubed root of 6 is our answer. Sorry, it looks like my pencil messed up a little bit there. Now, with this example, this is not something meant to scare you. It's meant to show you that if you truly understand factoring, roots, and simplifying radicals, you could do so many complex problems. We know that in order to factor something out of this fifth root, we need 5 of it. We need a group of 5. And what we do is the same process. We look for those groups of 5 to factor them out. If we have variables, it's the same thing. We look for groups of 5 of the same variable being multiplied by itself. And so let's start with 32. 32 breaks down into 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. Why is my pen doing this? Now what we can do is we can factor all those things, and we need 5 of them. So 1, 2, 3, 4, 5. Well, we have 5. This all results in just one value of 2 outside the radical. Now, if we're looking at x to the 10th power, we have 2 groups. I'll rewrite in a different color than green. I don't even think you're going to see the green. Here we have 2 groups of x to the 5th. X to the 5th, and I think you can imagine I can write out 5 x's, but I'm not going to. This entire thing can become factored out, which really just results in 2 x's, because we have 5 x's here and 5 x's here. Each of these factors into just one x when we pull it out. So now we're left with x squared on the outside. Y to the 6th power, well, this breaks into y to the 5th times y, and that y to the 5th will factor out and become just one y on the outside, one y will be left on the inside. And z to the 7th can be written as z to the 5th times z squared, which we can factor out this 5, and we'll be left with z squared inside the radical. So our final answer, we factor out a z, we're left with a y and a z squared inside. So we have y and z squared in the 5th root. Don't forget to write that 5 there. And this is our final answer. Again, this is not to scare you, it's to show you we can solve some significantly more complex problems if we know the principles of factoring and simplifying radicals. So this entire expression can be simplified down to 2 times x squared y z, all multiplied by the 5th root of y z squared. Lastly, we're going to take a look at how we can multiply radicals. I'm actually just going to move this over so it's what we can focus on here. Now, the 3rd root of 9, 9 breaks down into 3 times 3, so we can't actually break that down. The 3rd root of 24, well, this breaks into 2 times 12 and 2 times 6 and 2 times 3. Well, hey, this is going to work out well. We can take these factors of 2 out, and because it's a cube root, we'll be left with 1 on the outside, or 2 on the outside. So now we have 3 root 9, or the 3rd root of 9, times 2 times the 3rd root of 3. Okay, well, this is all multiplication, and we know multiplication is associative, so we can move things around. What we're really saying is 2 times the cubed root of 9 times the cubed root of 3. Let's think about that for a second. This 9 breaks into a 3 and a 3, and this cubed root has a 3. What we're saying is 2 times the cubed root of 3 times 3 times the cubed root of 3. That's our 3 different factors of 3. So really, it's just 2 times 3, which is all equal to 6. Don't believe me? Try entering in the cubed root of 9 times the cubed root of 24. You will get a value of 6. There are other ways to explain this, but I think this is the quickest way for you to understand. If you have questions, please let me know. Examples on some special right triangles we'll be going through.